Hi guys, today we have homogeneous differential equation. So this is actually the third method of solving first order differential equation. An equation is said to be homogeneous if and only if all the terms in the numerator and of the denominator are of equal degree. In the sense that okay, let's show how it works. The y over the x is equal to, let's say, the function of both x and y at the top and the function of both x and y in the denominator. So that's a function of x and y, the function of x and y. So now we say that an equation is said to be homogeneous when all the powers, all the degree of all the elements in the all the terms in the numerator are equal with that of the denominator. So we have equal degree in the numerator and equal degree in the denominator. So now watch. We have 2x squared plus 3xy over 4xy minus 6y squared. So if you watch this, you find out that the degree of all the terms, both in the numerator and the denominator, are the same. The first term is 2x squared. What's the degree? 2. The second term is 3xy. The degree of the variable here, x, is 1. The degree of the variable y is also 1. So in this term as a whole, the degree is what? 2. Then the degree of x here is 1. The degree of y here is 1. So the degree of both is what? 2. And here the degree of y is what? 2. So the degree of this term is 2, this term is 2, this term is 2, and the degree of this particular term is 2. So virtually all the terms in this equation are of equal degree. Therefore, this equation can be solved by substituting y equal to vx because it is actually a homogeneous equation. Hope you get it. Alright, let's get down to the first example. We have this equation. Solve the y by the x equal to 2xy plus 3y squared over x squared plus 2xy. So looking at this equation, it is a homogeneous equation. The equation is homogeneous in the sense that the degree of all the terms are equal. So we have the term here, the degree of this term is 2, the degree of this is 2, the degree of this is 2, and the degree of this is 2. We have the degree of y here to be 1, the degree of x to be 1, and of course we add both of them, we find out that this particular term is having degree 2 and this term is having degree 2, and in all round we have degree 2 in all. So the equation is homogeneous because the degree of all the terms in the equation are equal and they are of degree 2. Therefore, we can go ahead and solve by substituting y equal to vx. Okay, let y equal to vx so that the y over the x is equal to v plus x dv over the x. So the y over the x is now v plus x dv over the x. So we're going to remove this and then we'll replace it with this. And then removing the y over the x and replacing with this value, we have v plus x dv over the x to be equal to, then looking at this, anywhere we see y here, we have to substitute vx. So that we have 2x, y, and y is vx plus 3y squared, that's vx squared, when you substitute vx for y, all over x squared plus 2xy, that is 2x times y, and y is equal to vx. Okay, we have v plus x dv over dx is equal to, multiply out, we have 2vx squared plus 3v squared x squared, because the power is affecting both factors within the bracket. X squared plus 2x multiplied by that is 2vx squared. Right, we have v plus x dv over the x to be equal to, we'll factor out x squared from both sides, we have 2v plus 3v squared all over factoring x squared out, we have 1 plus 2v. Alright, to cancel out x squared from up and down, so we have left v plus x dv over the x, or definitely we can just cross, or can just taking v to that side, we have equal to 2v plus 3v squared all over 1 plus 2v minus, that's plus v crossing to that side, subtract v from both sides, we have that x dv over the x is equal to 2v plus 3v squared, everything here multiplied by v, we have minus v multiplied by 1 plus 2v all over 1 plus 2v by LCM. So we have x dv over the x is equal to 2v plus 3v squared minus v by 1 is minus v, by minus 2v is minus 2v squared all over 1 plus 2v. Alright, so we have x dv over the x is equal to 3v squared minus 2v squared is v squared, and then 2v minus v is minus, let's plus v all over 1 plus 2v. Okay, so that from here we can cross multiply so that we can separate the variable now, separate the variable v from the variable x, and then we'll cross multiply from here. We're going to have x dv multiplied by this will give us x into 1 plus 2v all dv equal to, then everything here multiplied by the x is v squared plus v all the x. So how do we do separating variable? And if you be following my video, you find out that this at this juncture it becomes very easy to separate the variable and arrange it very well. So how do we go about it? We needed variable v to come to the left and right hand side, or left hand side rather, and then variable x to go to the right hand side. So we're going to take v squared plus v, place it under here, then take out x and take it under here so that the x variable and the v variable are now separated, so that we have 1 plus 2v all dv divided by v squared plus v is equal to dx over x. We can just put it like this, 1 over x dx. So with this we can now integrate both sides. Find the integral of both sides. Find the integral of both sides. We are going to have alright. Alright. Integrating both sides now, you find out that integrating this denominator will give us 1 plus 2v, or 2v plus 1 is the same. So we're going to have ln v squared plus v to be equal to integral of 1 over x is ln x, then plus ln c or ln a. Use ln a, you can use ln c. Basically, I've said before in the other of my video that the differentiation of this denominator will give us the same thing at the top, because the differentiation of v squared is 2v, the differentiation of v, as the derivative of v is equal to 1. So basically, differentiating this denominator will give us the numerator. Therefore, the integral value of this equation now is ln the denominator plus c. Okay, so we have ln v squared plus v is equal to, then taking one of the logarithm and we multiply the number, this is ax. We take down the logarithm from both sides, we have v squared plus v is equal to ax. Then noting very well Recall that our v is equal to y over x because y is equal to vx, the substitution we made before. We now have y over x all squared plus y over x is equal to ax. So that this will give us y squared by x squared plus y over x is equal to ax, and the LCM here we can multiply through by x squared, multiply through by x squared, which is the LCM of denominator. We have x squared times x squared by y squared by x squared plus x squared by y over x equal to x squared by ax. So that x squared cancel out x squared with y squared plus 1 of the x squared, take away 1 of the x squared, 1 of the x here, take away 1 of the x here, we have xy equal to x squared multiplied by ax is ax cubed. Eventually, we have the final answer. Thank you and God bless you.